Hello everyone. The main goal of this section is trying to understand basic ideas that are sitting behind of sketching surfaces. We have already spent plenty of time to discuss planes and we touched spheres. Now our focus shifts to cylinders and quadratic surfaces. I will give you the definitions of those in a little bit, but let's first of all understand what are the basic ideas. The basic technique that we're going to use is founded or is using the so-called traces or curves that we get in the intersection of surfaces with planes parallel to coordinate planes. So we're consider all the planes that cross the surface and see what do we get there for every cross section. And those curves put together will give you some idea on how the surface is going to look like. Let's see how that works. First of all, we're going to focus on cylinders and see what is a cylinder. A cylinder is a surface that you get from a curve using or drawing all the parallel lines that passes through every point of that curve. Let's look at an image. We have a curve and we have all the parallel lines that are drawn through every point on that curve. Points on the parallel lines put together form a surface, and that surface is called a cylinder. The lines that we're considering here are called the rulings. Very roughly speaking, this could be understood as like putting a curve onto railings and just pushing them back and forth. Okay, so whatever you get there, you're gonna get, it's gonna be your surface or a cylinder. Let's consider an example. It says sketch the graph of the surface x squared plus y squared equals to 1. We're dealing with three-dimensional space, and you already know that z is missing in this equation. So because z is missing, it means that d can take any value. When z is 0, you get just x squared plus y squared equals 1 circle. When z is 1, you get the same circle, but it's a little bit higher. It's sitting on the plane z equals to 1. When z equals -3, it's the same circle, but sitting on the plane of z equals to 3, -3. So technically, changing the value of z, you get different circles that have the center at the z-axis, and all of those circles put together give you a cylinder, right? So let's look at this, right? So here's the circle on the xy plane. Now we're shifting up or down, and we get different circles on different planes, but all of them put together give you this cylinder. And now look at that. Every plane crossing that cylinder gives you a circle. Let's consider another example. Sketch the graph of the surface z equals to x squared. Let's see what is that. We see that y is missing here. If y is missing, it means that it can take any value. So if y is equal to 0, say that, then we get z equals to x squared parabola. If y equals 1, we get the same parabola, but with the vertex at y equals 1. If y equals -2, we get the same parabola, but with the vertex at y equals -2. So technically, this is a surface that's made of the parabolas that are shifted along the y-axis. Let's see. Here's the parallel lines, and here's the parabola. We shift the plane, and we get same parabola, but with the vertex that shifts along the y-axis. Now, if you put all the parabolas together, you're going to get this surface. Look at that. Every intersection is a parabola. This surface is called parabolic cylinder. Okay, again, it is called parabolic cylinder. All right, so this is how we can sketch the cylinders using their traces.